Good morning, all. In the previous video, we have discussed about a MANET. MANET means what? A mobile ad hoc network and a mobile IP, right? In this class, we have to discuss about a multicast routing protocol. So the next topic is what? After a MANET and a mobile IP, multicast routing protocol. What is multicast routing protocol means? What multicast means, it is a name itself, it is showing that multiple, right? Multicast means what? By using a single node, we are simultaneously we are sending the information to the multiple nodes. For that we are saying that a multicast. For example, about the multicast example is what? For video conferencing, like for Netflix and for TV channels and all, with the single only we are sending information or else movies to the multiple nodes, right? For that we can say it as a multicast routing protocol. What is meant by multicast routing protocol is multicast routing is a protocol that sends one copy of data to a multiple users. What is that? One copy of a data to multiple users simultaneously on a closed network. The most popular uses of multicasting includes video conferencing and streaming, video conferencing and streaming media, and organizational networks such as hotels and or campuses. For this, we can say it as a multicast routing protocol. By using one copy of data, we are sending a multiple users simultaneously. For that, we are saying that multicasting. So multicasting routing has numerous other uses. Although here is look at some of the most common ones is how it operates, the classification of multicast routing, and the most well-known protocols and examples that solidify it as a timeless technique. It as a timeless technique. So what is the purpose of multicasting is the principal purpose multicasting sends only one copy of data packet to a selective destination so that only devices that request the information receive it. Before getting here, routing tables identify endpoints to ensure they have to the correct address. They have to the correct address. So in contrast, unicasting sends one packet to one source, while broadcasting sends one packet to all sources simultaneously. Broadcasting sends one packet to all the sources simultaneously. So the purpose of this selective delivery is multifold. First, it optimizes loop-free topology, allowing the protocol to discover the shortest path for data reception. Second, it only attempts to send data packets one time, hitting nodes again if they submit requests. In general, multicast has low bandwidth requirements because it only sends the information stream. It only sends the information streams. This makes ideal for large quantities of data hitting several software and technologies like a media. There is a potential to increase or decrease. There is a potential increase or decrease bandwidth use because not every recipient will make presentist requests if they miss the multicast. However, repeated attempts from a few users should increase a traffic. From few users could increase a traffic. Finally, multicasting is extremely scalable as it makes data accessible to large number of peoples without the cumbrance nature of a broadcast. It should disperse traffic, so it's easy to oversee, preventing congestion and allowing room for support interference when needed. So how the multicast routing works is how the routings are works means multicast routing begins by sending a select group of receivers the data which they filter out the other necessary receivers. Means what? Multicast routing begins by sending a select group of receivers. We are selecting a group of receivers to send information of the data, which in that multicasting that has to be filter out the necessary receivers like tree branches, like a tree branches means necessary receivers only we are sending the information from the sender. So that's why these setups are often called multicast tree. So for this we can call it as a multicast tree. It's another way multicasting reduces latency and bandwidth because it doesn't attempt to send more transmissions that it can handle. So it's another way multicasting reduces latency and a bandwidth because it doesn't attempt to send more transmission that it handle. So diversifying the nodes responsible for dispersing the information helps receiver access data promptly. So would that information helps receivers access data promptly. So multicasting requires a server capable of handling multiple protocols. Otherwise, it won't operate well on LANs or WANs. LAN and WAN means what? It is in the computer networks we can call it as a local area network, and for WAN we can call it as a wide area network, right? Protocol independent multicast is nothing but a PIM, and interest group management protocol IGMP allow routers to fashion the tree branches and access data. So IGMP full form is what? Internet Group Management Protocol informs multicast redundancy points on how many recipients there are and where they are located. So multicast tree classification is how it classified means what? First one is a source based tree and the second one is the group shared tree. In the multicast routing tree, it has to be divided into two types. First one is what? Source based tree and a group shared tree and a source based tree. So for source based tree, we can call it as a SBT. In the short form, we can call it as a SBT. So multicasting tree classification is two multicast routing classifications demonstrate the protocol versatility. So to demonstrate the protocol versatility, source based tree and a group shared tree. They also accenture how multicast routing must work with the additional protocols for the purpose of optimization. So the first one is source based tree. So let us discuss about a source based tree. In the short form, we can call it as a source based tree. In the source based tree approach, the origin of multicast routing creates a tree and every group is directly traceable back to the starting source. At the same time, each node can continue to develop other branches because they each keep transmitting the source. They each keep transmitting the source. So SBT means a source based tree are annotated as source group. So they attempt to find the quickest route to as many receivers as possible. So trimming the distance the data travels each time it's transferred. Thus it is also known as a shortest path tree. Shortest path tree. For this we can call it as a shortest path tree. So the second one is group shared tree. So group shared tree we can call it as a GST. This GST is different and that government GST is different, right? So in the group shared tree, so GST sends a packets from multiple sources to coverage at the random point. The RP sends the forwards those packets down to the shared tree. So GST is a group shared tree. GST is nothing but a group shared tree. annotated as using the star G using the asterisk star in place of the source, since the source may be any number of different origins beyond the RP. So transmission can occur bidirectionally in this setup. Therefore, not every member has to be attached to the starting router or a core. Starting router or a core. So these two are the multicast tree classification. First one is what? A source based tree, and the second one is what? Group shared tree. So how is multicast routing supported? Multicast routing, it has to be how it can be supported. So while sending from single source to a multiple receivers simultaneously, how it can be supported. So multicast routing is not a default and may not be supported on every network. So where supported users can toggle it on and off the network's settings. You can configure your router to support any multicast routing protocol. The host is then assigned an IP. The host is then assigned the IP address that receives downstream and easily identify. So once the host is assigned the IP address that the receiver downstream can easily identify. The receiver downstream can easily identified. In the mobile IP, we have know about the what is the mobile IP and what is meant by IP address and all, right. So once the host is then assigned the IP address, that receiver downstream can easily identify. So it uses a multicast forwarding information base and sends information to the routing information base. So these keep communication open with the protocol and track data transmission speed and bytes. So by using these for MFIB, so the multicast forwarding information base and the information to the routing information base, by using this keep communication open with the other protocols that track and transmission speed as well as a bytes, how the speed has to be transmitted the data and how many bytes should be transmitted. So in this there are three topmost routing protocols. The first one is a dense mode, and the second one is a sparse mode, and the third one is the reverse path forwarding. So let us discuss about the dense mode. First one is a dense mode. What happens in the dense mode? In dense mode, the source will distribute the data to every subnet included in the multicast network. This is also called flooding because it sends packets with less discretion than other protocol variants. So not every router has to accept the package, though prune messages can notify the sending nodes to exclude them from the receiving information, which helps trim unnecessary data emissions. So in this dense mode, what happens? The unnecessary data cannot be trimmed, and whatever the data has to be received, prompt data has to be want to receive, that data has to be transferred to the receivers. So in PIM protocol can work in a dense mode multicast routing type because it creates as many short pathways to recipients as possible. So PIM protocol, what happens, can work in the dense mode multicast routing type because it creates as many short pathways or recipients as possible. So in the second mode, what is that? A sparse mode. First mode is what? In topmost multicasting routing protocols. First one is dense mode, and the second one is sparse mode, and the third one is reverse path forwarding. And in the second sparse mode, whereas a dense mode mass releases data to connected networks, So sparse mode only take the time to do so if there is a request. Whenever the request should be there, at that time only the sparse mode only takes the time to do the so if there is any request from the receiver end. So protocols like this reduce the bandwidth usage and allow nodes joining the multicast group to receive data over time when they initiate specific request. When they initiate specific request, receivers can initiate a request at that time group to receive a data over a time when they initiate a specific request for information. So like dense mode, there is also a PIMI sparse mode. PIM sparse mode. So the third one is reverse path forwarding. So in the reverse path forwarding, what happens? Reverse path forwarding implements a self check. In the reverse path forwarding, it has to be a implements a self check. So nodes can't receive the same information they sent because the sender won't look at that interference. So though multicast routing optimizes for a short path, it can sometimes lead to loop when packets continually find other connected nodes. In such cases, it can unintentionally waste resources by sending a data back to the original sender. So reverse path forwarding allows a more intentional sending and a receiving of data. So this is about the reverse path forwarding. This is the third one. The top three most multicast routing protocols are what? One is dense mode, and dense mode. Next one is sparse mode, and the third one is reverse path forwarding. So, what are the examples of multicasting? There are four examples of a multicasting. First one is streaming. Streaming means what? Like we are seeing the channels, right? The TV channels. For that, we can say it as a streaming. And next one is video conferencing. And the third one is file distribution. And the fourth one is IoT devices, right? These are the four examples of multicasting. So first one is streaming. Streaming means what? In this, one of the most widely used multicasting application is allowing video or other media to the delivered to either to be delivered to users across a corporate campus, school, or hotel property. Live streaming of events and concerts. It also sometimes done via a multicast. So for this we can say it as a streaming. And the next one is video conferencing. What happens in the video conferencing? So video conferencing, we all know about like Zoom Meet, Google Meet, and all the things we are using right nowadays. So in the video conferencing, Zoom calls to mass video training sessions. Multicasting allows many entrants to participate in the same event without overwhelming the server. Without overwhelming the server. For that, we can say we are using right now Google Meet, Zoom Meet, and etc. Right, in that we are conducting some online classes and all in the video conference and all. So in that there are so many of the students can join without interfering the server and all, right? Because in that server some restriction should be there. So only host can be say something, or else host can be say something about the whatever the class, or else whatever the meeting I should meeting and all, right? So for that we are saying that a video conferencing. And the third one is file distribution. What happens is the file distribution over the air patch management, operating system, imaging, and even financial stock tickers can all be multicast over a corporate networks. For that, we are saying that file distribution. Next, last one is IoT devices. What is that IoT devices? The sensors embedded into IoT devices translate and send information to databases, AI, and countless other sources when it collects informations. So these systems may rely on multicasting to keep tabs on cyber security and ensure the correct recipients. Right? For this, we are saying that the IoT devices. So the four examples of multicasting is what? First one is streaming, second one is uh, video conferencing, and the third one is file distribution, and the last one is IoT devices. IoT devices means we are using IoT devices, right? Like Alexa and all. For that, we are saying that IoT devices means that that should be a sensor based. So for that, we are saying that IoT devices. So this is all about the multicast routing protocol, right? That four examples of multicast routing protocols. And the last thing in the multicast routing is multicasting could apply to large scale professional training experiences or gaming events through virtual reality. The responsibilities, the possibilities are continuing to expand. New technologies come into the fold, stretching the abilities of what and how multicast can transmit experiences across a networks. It should be noted that a content delivery networks such as Netflix, although sharing many characteristics with the multicasting, are typically done via unicast. Although this may increase a latency on the organization's home network, it enables greater flexibility in dispersing media on demand over the internet. So all this should be over the internet only happens, right? So for this, we can say it as a multicast routing protocol. So in the multicast routing protocol, there are the most four main examples. Most used examples is what? Streaming, video conferencing, file distribution, and IoT devices. Right? In that, we are having a three three types of multicast routing protocol. First one is dense mode, sparse mode, and the reverse path forwarding. So this is all about the multicast routing protocols. Thank you.